Hi everyone, this is Tim from Maker's Machining. I'm here with Derek. Derek's in the early years of high school and he's considering a job in engineering. And I think I've mentioned on other videos before that if engineers would spend a little time in a machine shop to learn how things are made and processed, it gives them a pretty good idea as they're getting into engineering here. I can think of many examples where guys have spent time in a machine shop and have done very well as engineers. So we're going to do a little bit of work here this evening and see how to do some basic cuts and use a little math. You can tell we're in the COVID-19 era here because we got the masks on and our glasses are getting steamed up. It's kind of difficult. But what we're going to do here today is we're going to cut a keyway in a shaft. One aspect of machining out of zillions. We're going to get this cut, and I'm going to show you a couple different ways to make sure that your cutter is in the center of the shaft. So if your keyway is in the center of the shaft, you don't want a keyway that's offset and try to slide a gear or a pulley or a sprocket over it, and then the keyway and the key won't fit together. So we got to be pretty close to center. Perfect is ideal, but we're going to see where we're at. So we've got a couple things in here that are set up to show you. I've got a shaft in here, and we've already qualified the machine. What I mean by that is we made sure that the vise is dead straight on the table. We've run an indicator against the back side of it. It is dead true. We've also checked that the spindle of the machine is exactly perpendicular to the table. And we've put the indicator on here so it swings around and we can check to make sure it's square. Not kind of square, but square. I think we were at less than 1/1000th of an inch off over a 6-inch circle, so that's pretty good. So the next thing that we did, we got the indicator here. This indicator here shows there's big lines and small lines. It's a 1/2,000th between each of the big and small lines. And I'm going to bring this thing down here. Excuse me. I'm going to bring this thing down here and get the indicator on here. I've got this machine in neutral. I'm not going to bump the needle against the vise jaw right away. I'm going to swing it around and turn this thing, and it comes up to 0. Maybe goes 1/2,000th past. And then, Derek, you take a look on the other side. When I get this, when I get the indicator comes around the back side there, does it come up to 0 again? Can you see that? That's a good idea.
Yep.
Derek's dad is behind the camera here, so so we've got 0 basically on both sides of the vise. That means we're in the center of this shaft. Whatever the diameter of the shaft is, we're centered in the shaft. This shaft happens to be 1 3/8 in diameter. So if we check that with the caliper, 1 3/8 is also 1.375 in fractions. You got your decimal equivalent chart there, Andy? We got these little charts here. I don't think I've got an extra one here, but we can find the 3/8 on here wherever it's at. 31/64, 11/32. There's 3/8 in the red. So that's 0.375 is 3/8. This is a handy chart, this Starrett chart, because it shows all the drill sizes, all the fractions, all the letter drills. There's numbers, letters. There's U, V, W, X, all those different size drills, and then there's also fraction drills. On this chart, it shows what those equivalents are in decimal and fraction. The back side continues all the way up to 1.5 inches. It gives all the numbers there. On the bottom, it's got all the pipe thread sizes and the hole size that you have to drill to tap that hole. Over here, it's got all the metric size threads and the size drill you have to use in millimeters or in inches. So this is a handy chart here for everybody to have. So we're at 1 3/8 diameter shaft, and we have a chart here that tells us. I copied this page out of the Machinery's Handbook. That's the Bible of machining. I don't know what, page 2266. It's a big thick book. It's got information that you couldn't even imagine is in there, but if you need it, that's where you can find it. That particular book there is about 30 years old. But anyhow, this chart is on one of the pages in there. And so we got an 1 3/8 shaft. So that's somewhere between 1 1/4 and 1 1/2. So it's the diameter of the shaft is 1 1/4 to 1 1/2. And you come over here, it's a 3/8 keyway what we've got to put in there. So what it shows up here is if your W is the keyway width, your keyway has to be half in the shaft and half in the hub or the gear or whatever you're putting on the shaft. That way it's got equal load on it. And I want to point out that where you take that reading from is in the shaft. You have to start your dimension from where the cutter makes a full width mark on top of the shaft, and that's where you do your depth of your cut. In the hub of the gear or sprocket, whatever you're doing, that same dimension starts where the cutter touches up at the both sides of the bore, and then you make your cut up into the bore to get the other half of the keyway, plus a few thousandths. I always go an extra 5 or so thousandths deep because you want to make sure that the keyway goes in there. So here I'm showing the shaft dimension goes from where it has a full clean cut across there, which you'll see in a minute. The bore, it's where it touches on the both the sides of the cutter in the bore, if that's clear. But you want to make sure you get that keyway deep enough, because if some guy in the maintenance department wants to go up and put a fan on a shaft or something, and you haven't cut your keyway deep enough, he's going to get up there and he's going to be holding that key in his mouth and putting everything lined up, and he's going to go to push it in there and it won't fit. He won't be happy. He'll be coming looking for you. So anyhow, we're going to take a look at how much time we got in this thing. It's kind of got, we're halfway done there. We got to talk fast here. So we already know that we're centered with our spindle over our shaft. We know that we're there. There's different ways to check the center. Talking about keyways, they're used to drive devices from a motor to a shaft to a pulley to a gear. Even the keyway in this collet here has a mating key up in the spindle here. You line it up and up she goes, and you can you can lock it in with whatever. If you got a drawbar, power drawbar like this, we can put this wiggler in there. Oh, I got this thing in neutral here. You can see this wiggler here is used for catching the side of a part, and it can get you accuracy within 1/1000th of an inch or so. So I'm going to go over here, and that small diameter is 200,000ths of an inch. So I'm going to turn this thing in, and you can see it getting more and more concentric. And then all of a sudden, when it's at that point, it's going to jump. You'll see it. I'm slowly turning it. Okay, there we are. So we're within 1/1000th of an inch of having this 200,000th diameter pin in line with the back of the vise. So I turn this thing off to lift this off of there, because there's a screw and a spring in there. If you happen to get that thing up and just catch right, it'll unscrew that piece off of there and you'll never get it back on. Okay, so where we picked up here, we need to move our table 100,000ths closer to get the center of our spindle on the edge of the piece. If you look at the readout here, we're in the Y, we're at 586. So we're going to go back to 686. Okay, so now our spindle is dead center on the back vise. So if you do the math, we're at 1.375. What's half of that? 0.687. 686 and a half, somewhere around there. So we're within 1/1000th of an inch of being on the edge from the center of our part. I've already set this up, so I know that that was the number that was going to show up there. So I'm going to go back to 0, and that's the center of that shaft. So I hope you followed that. We picked up the edge of the vise, moved over 100 thousandths, and it was half the number of what our shaft diameter is. Okay, so we're centered in the shaft. Okay, so now we're going to put our cutter in. Excuse me. We got two different kind of cutters here. This cutter here is a center cutting end mill. You can see on the tip here that the cutting edges go to the very center, and if we plunge this thing down in, it acts like a drill bit and it can go straight down and make a hole. It's a 2-flute carbide end mill. On the other hand, here's a high-speed steel, which doesn't make a difference if it's carbide or not, but it's got a hole in the center. So this thing won't be able to plunge straight down to the depth we want because there's no way to get the chip out of the center. So we're going to use this center cutting carbide end mill to cut our keyway. Got all this, Derek? Figured you did. Okay, so I got the keyway in there. Push that in there. Hold the drawbar tight. We're good. All right. So what we're going to do here now, you got to be careful with carbide, because if I come down and bump the part, it's going to chip the carbide. I'm going to drop the table down low enough so I'm sure it doesn't hit. And I'm using my quill stop up here as our stop. I'm going to lock this quill down at that point. So that's a Z reading here. I'm going to zero out my Z just for grins. Okay, so now you can see that if I go up or down, I come back down, it's at 0. Okay, so I'm going to turn the RPM down just a little bit. And now our cutter's all the way on the bottom. I'm going to crank this thing up, and you'll see it start to cut. You can see it start to cut that circle there, but it's like a D shape right now. Let me lift this thing up. It's not all the way down, so it's got two flats on the side of that circle. Okay, so once we get down all the way, I'm going back to my 0 reading on Z. I'm going to crank this thing up. It's a center cutting, so it'll cut that right out of there until we get our full circle. Looks like we got it there, eh, Mike? Yep. Okay, let's take a look. Got a perfect circle there, okay? So, we know where our 0 reading is at, so I'm going to set my dial here on the handle, and we're going to go half of 3/8, which is 0.1875. I've got some marks on the table here. I've got to swing around here to turn this thing. I got some marks on the part here that shows where the keyway is going to get cut. If I come over here, I can touch it off and get the circle. This thing's sitting nice and flat, so I go to my 0 reading again, and I've got a flat circle there. Okay, let's say you don't have an indicator to check it with. If you want to get pretty darn close without having an indicator, let's say you eyeball it and say, okay, I think this is about centered. You come down and touch this thing, and you're going to see it's not a round, universal shape, symmetrical mark. So that tells you, okay, I got to move over a little bit. Still, it's got more of a flat on the back side than it does on the front side, so I'm going to move over a little bit more. I'll come down there. It's still not round all the way, so I'm going to move over some more. Still a little bit of a flat. I'm going to go some more. Must have the COVID. Come down to my reading, and I got this centered nice and round without using an indicator here. So we got the reading that we want, and we're centered. And look at the Y up here. It's on 0. I was kind of cheating because I was looking at to see where I was at with 0. But if you want to cut a keyway without an indicator, that's how you can do it, by kind of gradually making a cut on top of the shaft. And if you run out of space and you're not quite sure and you want to try it again in another location, you can go all the way up and down this thing to get your cut made. So, okay, we've got our keyway lined up, and I've got my zero reading on my I'll show you my dial down here. I'm at 0. I'm going to be at 0 with my end mill on the Z. I've got to move this thing up 187 thousandths. As long as my Z doesn't move on the readout, I can plunge this thing straight down. 80 thousandths, 90. The Z hasn't moved. This is a brand new carbide end mill, so it's going to cut real nice, I hope. 140, 150, 70, 80. I'm going to go to 190. I'm going to go 3 thousandths past the depth of the key. Now, now I'm going to move left to right, and we're going to have our keyway cut in there. Normally you could use coolant on this and get a little blast of air or a brush to keep that stuff out of there to see where you're going. But I'm just going to make a short cut here because I think we're going to run out of time here momentarily. We already did. We're past our time, but I think we can crop a little bit of time off there. And we're able to cut the keyway. Derek, you want to come over and turn this thing? You're cutting a slot in a piece of solid steel. Use your hand here instead of the handle. That way you can kind of feel if it's going okay. But go ahead and go a little faster. Otherwise we'll be here at lunchtime tomorrow. You can feed it a little bit there. Our Z is still at 0 up there, so we're looking good. So anyhow, if you got to cut a keyway in a shaft, this is an easy way to get the setup in there. Get your vise straight, get your head square, then everything will work out good. We indicated the center, just a little recap here. We indicated the center. We got the vise tight so it doesn't come out of there. So anyhow, it's cutting along pretty good. I think we'll shut it off here. We've got the keyway in here. You can quit turning. I'm going to lift this thing out of there. I don't have a brush here. But you can see the little marks that we made. Let me get the air gun here. We'll get a little puff of air. Get my machinery's handbook out of there. Okay, so you got a nice keyway in there right now. So we'll be able to put a key in there. A lot of times the key stock that you get at the hardware store is galvanized and it's a little bit fat. So you might have to push a few thousandths in there or sand it off a little bit. But that's an easy way to cut a keyway, whether you've got an indicator or not. So we'll turn this thing off here. Got to get a picture of Mike and Derek together here. They came out here to do a little homework. Mike and I have known each other for quite a while, and the young guy's contemplating his career. So I think they're smiling back there. I'm not sure. It's getting kind of late. These guys might be. There we go. There you go. Oh, that's good. I can recognize you now. So anyhow, thanks for coming out for today's session here.
Thanks for having us.
You're more than welcome. Check out Maker's Machining. So long.